All right, so hello and welcome back. Today we are prepping for our semester exam. So that should be one of the last things that you are doing as you finish out. Today and tomorrow are the last 2 days of the course. And before we do that warm-up problem and before we jump into the activity, just want to remind you that you do need to do the semester exam. It is a requirement to pass the class. And it is also a requirement to get both of your discussion-based assessments done. Everyone has so far, except for one person, but they have scheduled it. So most people don't need to worry about that right now. But yes, you do need to have 2 DBAs completed in order to receive credit for the course and your semester exam done, regardless of the grade that you have in the class. So even if you have an A with a 0 in for the semester exam, like you need to do the semester exam to really achieve that credit. So we do have a question in the chat, and yes, if you have already done your semester exam and you feel like you don't want to stay for the lesson, that is totally up to you. The live lessons aren't necessarily mandatory. I mean, there's some points in there for like the honors projects and stuff, but you are not required to stay on a live lesson if you'd rather, work on your missing assignments or things like that. So I'll leave that up to you. But good question. So yeah, other things that should hopefully be done by now, if they're not already, are your unit tests. So unit A through unit E, your ALEX objectives, and any other missing assignments. So if we go to the PACE calendar, which I did not include in here, but I do have it on my screen. All right, if we go to the PACE calendar to today, which is Tuesday the 28th, you should hopefully be doing your semester exam today and submitting any remaining topics learned in Canvas. And then tomorrow is the last day of the course. Complete any missing assignments or anything that you want to redo for a higher grade. All right, any questions about that? And then on this slide here are some general resources for your semester exam. So we have a Jeopardy link, which we'll go through today, a booklet review game, a printable geometry review, an optional exam that you can take in ALEX, theorems, proofs, postulates, formulas, reference, ALEX topics videos with highlights, and then of course a link to the Desmos free calculator. So all of that is provided in the daily slides today, which are also in the homepage on Canvas. All right, so in that case, we'll go ahead and get started with the Jeopardy game. And I'll put for 3 teams, even though we do have a much smaller group today. Maybe some people will join later, but if you've never played Jeopardy before, essentially there's different categories worth a different amount of points. Usually the more points that it is worth, the harder the question is. So I'll add some initials of the people that are here. And then we'll just go ahead. Normally, like with my own students, I would have them, either on a whiteboard and show me, or we even do the virtual whiteboards. But since it is a small group and I think it is manageable, we'll go ahead and throw those questions into the answers into the chat. So Jacob, either on your microphone or in the chat, go ahead and pick which category you would like to see and for how many points. All right, so segments and angles for 200. All right, there is a question. Classify as a line a segment, or array? And normally I would have people wait to submit their answers, but since it is kind of a smaller group, go ahead and submit your answers as you have them. And yes, this is in fact a array. Hold on, let me get it on here. All right, so it is a array. Now, keep in mind a line for these other ones. Let me go on the annotate button. All right, so a line, remember, goes infinitely in both directions. A segment has two endpoints. An array has one endpoint and then a side that goes on infinitely forever. So keep in mind, the way I think of it is like ray, like a stingray, like that's what their tails look like. And then also when you're writing your, like if you were labeling this to show that it's a ray, then the line above it would look like a ray. So something like that. If we were talking about line A, then we would have the arrows on each end. Or if we were talking about a segment, then it might just look something like this. All right, so watch those for your tests, the symbols and how to write them. All right, so now next one. Which category would you like? And I meant to put the points. Let me go back if I can. All right. Which category would you like and for how much? All right, algebra review for 400. All right, so what is the solution to negative 56 equals negative 8 times the sum of x and 6? All right, so we say x equals 1. Let's see if that is correct. And that is correct. Now, there are two ways that you could go about solving this problem. I'll go ahead and show both for anyone out there that is watching the recording. So first thing that you could have done is distribute that negative 8 to both terms in the parentheses. All right, so multiply by each term, you get negative 8 times x is negative 8x. Negative 8 times 6 is negative 48, equal to negative 56. And then solving for x, always start with what's farther away from it. So in this case, we would add 48 to each side, because that would cancel out the negative 48. Negative 56 plus 48 is, and I'm really bad at mental math, so I'm just gonna save myself the trouble and throw it in my calculator. All right, so that would be a negative 8 equal to negative 8x. Opposite of multiplying by negative 8 is dividing by negative 8. And then we get x equal to a positive 1. All right, the other way that you could have gone about it is, again, always start with what's farther from the x, which would be this negative 8 because the 6 is inside the parentheses with the x. Another way you could have gone about this is divided negative 8 on each side first. You would have had a positive 7 on the left side equal to x plus 6, and then subtract 6 on each side. And then again, we get that x is equal to 1. So if you did it one way or the other, you are correct. As long as you follow the steps correctly, you should still get x equals 1. So good. Now go ahead and pick the next category and for how much. All right, polygons for 100. There it is. True or false, all squares are also rectangles and rhombi. True or false, all squares are also rectangles and rhombi. All right, so we're saying true. Let's see if that's correct. And actually, let me go back and give you those points for the algebra review. All right, let's see if this is true. And it is. So keep in mind, there are certain criteria for each different type of quadrilateral. Squares have all sides the same, or all sides equal length, and 4 90-degree angles or 4 right angles. So squares can also be rectangles. The criteria for rectangles is that they have 4 right angles. They have 2 sets of their opposite sides are parallel to each other, which is also a property of a square. And that is also true of rectangles, right? And I'll just kind of abbreviate this. Opposite sides are parallel. All right, the way that rectangles are different is that their sides don't necessarily all have to be equal length like squares do. So a square is a rectangle, but not all rectangles are squares, right? But it does meet those 2 criteria. And then for rhombi, those have it where all sides are equal lengths. And then that the opposite sides are parallel as well. All right, so they don't have 90-degree angles, which is why rhombi can't be squares, but squares can be rhombi, in which that they have all sides equal length and opposite sides are parallel. So squares are always like the most specific compared to the rest of the quadrilaterals. All right, so let's try the next one. All right, which category and for how much? All right, similarity for 300. All right, so we have 2 problems in this one. First, are these congruent similar for this rectangle and square, and then 2 triangles. Are they congruent? Are they similar? Both? What do we think? All right. So let's see. First, before I reveal the answer, let's talk about congruent and similar. So items that are congruent have the exact same side lengths. So same side lengths and same angles. Essentially, they're the exact same shape, right? Now, if they are similar, what is identical between similar shapes? Well, they have the same angles. They do not have the same side lengths, but their side lengths are proportional. All right, and proportional is the correct way of basically saying each side is multiplied by the same number. So when we're looking at example A, well, obviously they're not congruent. They do not have the same side lengths and angles. But let's see if they're similar. So I have this side has 2 units. This side over here, 1, 2, 3, 4, has 4 units. When I compare it to this square looking shape, 2 units by 2 units. Well, there's no consistent number that I'm multiplying each side by, right? To go from 2 to 2, I would have to multiply 1. To go from 4 to 2, I'd have to multiply 1/2. So that means that they are not proportional since I'm not multiplying the same number on each side. So we are correct so far in that A is neither congruent or similar. For B, they are congruent and similar. All right, so for the same side lengths, definitely take a moment and measure it. So I have 1 unit for the base and 1, 2, 3 units for the height. By definition of our Pythagorean theorem, we could solve for the missing side, the hypotenuse. This is clearly a right triangle because it lines up on that grid nicely. And we know that whatever that side equals, it's going to be the same. And then because we have the 3 sides of a triangle the same, well, they're congruent by side, side, side. All right. And then similar is also what it is. And I know some students get tripped up about that. So it is congruent and it's also similar. So similar shapes aren't necessarily always congruent, but all congruent shapes are also similar because their side lengths are proportional. It's like multiplying each side by 1 to get to the next shape. So they are technically similar as well. So you are correct. All right, and then let's go ahead and give you those points. And just verifying that we have the right answer. All right, so good job. Now pick the next category and for that many points. Reasoning and lines for 500. All right, so this is a great example. We have the equations of 3 lines are given, and you're going to determine whether lines 1 and 2 are parallel, perpendicular, neither, and so on for lines 1 and 3 and 2 and 3. So go ahead and try that one. All right, anyone watching this recording is welcome to pause, try it out, and then see if you get it right. That's why I'm also going through and explaining them, even though we so far are getting them all right. All right, so we're starting to get some answers in. Keep in mind, this problem I really like because it asks you basically to have a good knowledge about multiple things. First, you need to know that parallel lines have the same slope, different y-intercept. And I'm just going to abbreviate that. So ideally, you would like all of your equations to be in slope-intercept form. Y equals mx plus b. Remember, m is for slope and b is for your y-intercept. So one thing that even sometimes trips me up when I'm just trying to do a problem really fast is I'll look at the way that it's given to me and I'll just instinctively look at the number that's in front of the x and assume that that's my slope. All right, but if it's not in y equals mx plus b form, you can't do that. So line 1 is in y equals mx plus b form, but line 2 is not. So I'm going to take a moment and rearrange line 2. All right, so 6x plus 4y equals 8. Notice in slope-intercept form, the y is by itself. So that's what we're going to do. We're going to isolate the y. So we're going to subtract 6x on each side. So always get rid of what's farther from the variable that you're trying to isolate. I get 4y equals negative 6x plus 8. Opposite of multiplying by 4 is dividing by 4. Remember to do that to each term on the other side. And I have y equals negative 3 over 2. So simplify that fraction, x. And plus 2. All right, so just to kind of make this easier to read, line 1 has a slope of negative 2/3. Line 2 has a slope of negative 3 over 2. So since that is not the same slope, right? I know that lines 1 and 2 are definitely not parallel. To see if they're perpendicular, you also have to know about perpendicular lines. Those have slopes that are negative reciprocals. All right, so break each word down. Negative means that it should have opposite signs. So if it started out positive, the negative reciprocal will be negative. If it started out negative, the negative reciprocal will be positive. So since line 2 and 1 have them where they're both negative, they're not opposite signs, then they're not perpendicular. So the answer for whether line 1 and 2 are parallel, perpendicular, or neither. All right, those two lines are not parallel or perpendicular. So you are correct in that. Good job. They are kind of reciprocals of each other, like they did flip the fraction, but they're not negative reciprocals. So then let's keep going. For line 3, again, do not be fooled by the way that it's formatted. Slope-intercept form has it where the y is by itself. And in the line 3, it's almost by itself. So let me rewrite it over here. I need to get rid of that 3, that's by the y. Opposite of multiplying by 3 is dividing by 3. All right, so when you're looking at it just really fast and you don't see that the y isn't by itself, that could really trick you on a test. All right, and here is what line 3 is in slope-intercept form. So that slope is negative 2/3. So when I'm comparing lines 1 and 3, that's what we have to compare next. Compare the slopes. Line 1, line 3, are they the same? Are they negative reciprocals or are they neither of those? And since they are the same, then they are parallel for 1 and 3. All right, last one. We are looking at we're looking at lines 2 and 3. So let me highlight those. And the answer should be the same as when you compared line 1 and 2. The answer should be neither, because we're comparing -3/2 to -2/3 again. Since they have the same sign, they're not negative reciprocals, they're just reciprocals. They flipped the fraction, they didn't also make it negative. So good job on this one. Any questions? Right, so this is a really great test question. It asks you to know a lot of things. It asks you to know how to rearrange equations into slope-intercept form. It asks you to know the difference between parallel and perpendicular lines by comparing the slopes. So good. All right, which category would you like next and for how many? All right, polygons for 400. So here's the problem. Which triangle congruence property is used in the conclusion of this proof? Which triangle congruence property is used in the conclusion of this proof? All right, so we have put in the chat our answer. Let's see if you are correct. And you are correct. It is side, side, side. So other things that you might have seen in this proof is the reflexive property, because they did not tell you explicitly that PR is concurrent to PR. All right, but there is the reflexive property that tells you that the same sides are congruent to each other. Meaning, like, if I'm using the same line as that side on two triangles, then they will be congruent to each other. And because that's congruent, and then of course the other stuff that they gave us, that QR is congruent to SR, and that PQ is congruent to PS, since we have 3 congruent sides, through the side, side, side congruence property. So good. All right, let's do the next one. All right, which one would you like and for how much? Reasoning and lines for 500. I think we already did that one. Maybe 400 instead. Let's try that one. All right, so consider the line 7x plus 4y equals 3. What is the slope of a line perpendicular to this line, and what's the slope of a line parallel to this line? All right, so go try that one out. All right, and while you're submitting your answer, I'm going to go ahead and start explaining. So first thing you always need to make sure of is that your equations are in slope-intercept form. All right, so in this case, it's not, it's in standard form. So we're going to isolate the y so that I can clearly see my slope, because as you remember, when we're talking about parallel and perpendicular lines, we need to have slopes that are, well, we need to be comparing the slopes essentially. So in order to isolate that y, start with what's farther from it. So that's 7x. Think, what do I need to do to make it 0? So to make that 7x 0, I'm going to subtract it. And it is a rule that whatever you do on one side, you have to do it to the other side. So then I have 4y equal to, and these are not like terms, so you just rewrite them next to each other, negative 7x plus 3. Opposite of multiplying by 4 is dividing by 4. Make sure you do that to each term. All right, and then y equals, your slope can be a fraction, it just needs to be a simplified fraction. Negative 7/4 x plus 3/4 or plus 0.75, either way. Now, remember the key thing here is our slope. Since my slope is negative 7/4 in my given line, the slope of a line perpendicular, do we have an answer to this one yet? Good. The slope to this line, that would be perpendicular, so flip the fraction and have the opposite sign. So since this was negative, the one perpendicular to it would be 4/7. Parallel should be exactly the same. So negative 7/4, same as the given line. Good. So then now let's do the next one. All right, which one would you like and for how much? All right, algebra review for 500. So we have Alonzo is staining the wooden floor of a court. The court is in the shape of a rectangle. Its length is 33 feet. Its width is 32 feet. Suppose each can of wood stain can cover 132 square feet. How many cans will he need to cover the court? So go ahead and try that one. And while you're trying that one, I'm just going to do something real quick. My dogs will not stop barking, so I'm just going to go quiet them down while you do that. All right, so we have an answer of 8 cans. Let's see if that is correct. And you are. So for this one, you need to have knowledge of area of shapes. So for the area of a rectangle, that formula is length times width or base times height. We'll do length times width. And since our length was 33 feet and our width is 32 feet, we multiply those together. 33 times 32 is 1,056 square feet. And if each can of wood stain can cover 132 square feet, well, the next thing to do in our problem solving is to divide our total square feet by how many feet each can covers. And when I do that, I get 8 exactly. So it worked out to have exactly 8 cans be my answer. Now, let's say, for instance, that what I got from dividing was actually a decimal. Pretend that it was like 8.3. Now in rounding rules, like in normal rounding rules, you would round it to 8 rather than 9. But since we're talking about how many cans that they would need to cover the court, if that were the case, then we would have to have 9 cans. 8 cans just would not be enough. So in that case, you would have to round up regardless of how close it is to the other number. So just keep that in mind in case you see that on a test. In this problem, it worked out to be exactly 8. So good job there. All right, let's do the next one. All right, which one and for how much? All right, segments and angles for 300. So in the figure below, measure of angle ABD is 94 degrees, measure of angle CBD is 66 degrees, and BE bisects CBD. Find the measure of angle ABE. I'll do my best to zoom in. It actually worked out really well. So go ahead and answer this one. All right, so we have an answer of 61 degrees. Let's see if that is correct. And you are correct. So here is where I got so far. So for this problem, just really try and get a good picture of where all the given information is. So first is that the measure of angle ABD, so this whole thing right here in green, is 94 degrees. Then we have that CBD, so just this portion, is 66 degrees. And then we have that angle or that line BE bisects CBD, meaning that where it is in red, basically this side is 33 degrees. And so is this side, because remember, bisects means that it cuts evenly in half. And it only cuts CBD in half. So since CBD is 66 degrees and, cut it in half, that means each part right here is 33 degrees. And then we need to find the measure of a BE. So this portion right here is what we're trying to find. So in this case, I already know that CBE is 33 degrees. I really just need to find that measure and then add it to 33 degrees. So since I know that this entire angle is 94 degrees, and I really just need to find that portion and add it to 33, I can do 94 minus 66, which is 28. And then when I do 28 plus 33, that is how I get 61 degrees. So like this portion, and I'll do it in pink as well, is 28 degrees, and we're looking for the measure of this in the blue. All right, so 28 plus 33 gives me 61 degrees. Good job. All right, so let's see the next one. Which one would you like and for how much? All right, polygons for 300. So identify the transformation for each of the following. What type of transformation is each of the following? All right, and while you are answering, I'll go ahead and start breaking it down. Remember that translations are kind of like sliding an object in one direction. So translations do not alter the shape or size of the shape. All it does is basically move the shape to a different location. No difference in orientation or anything like that. So you are correct in saying that A is a translation. And then I'm just kind of going down the bullet point list. Reflection, think like mirror images of each other. Like when you look in the mirror, you see your reflection, or when you put your hands in front of each other, they reflect each other, but your hands are like in different orientations, right? So for your reflections, think mirror image. And there will always be over a line of reflection. And between these three different types of transformations, C is a reflection. Now for example B, let's see if that is a rotation. So a rotation basically shifts an image around a fixed point. So it is around a fixed point. Usually there's rules to rotations, like if you reflect over the x-axis or I'm thinking reflection. If you rotate like clockwise 90 degrees or counterclockwise 90 degrees or 180 degrees rotation, there's usually rules associated with that. So in B, that one is a rotation. And this would be the point that they are rotating it around. All right, so good. One more will do. So which one would you like and for how much? All right, similarity for 200. All right, so in a scale model of a television, 1 centimeter represents 10 inches. So answer the following. In the scale model, the height of the television is 5 centimeters. What is the height of the real television? And then part B, a different question. The length of the real television is 80 inches. What is the length of the television in the scale model? All right, and you're fast. If you're watching the recording, feel free to pause if you don't want the answer just yet. But it looks like we already have some answers. So in this one, let's start with A. We have in the scale model, first of all, scale models always have something called a scale factor, which is another way to say a proportion. So what we're essentially saying is that, and this is my scale factor right here, for every 1 centimeter, it's equal to 10 inches. So I'm going to set up my proportion that way as centimeters over inches. You're welcome to do it as inches over centimeters if you like. Just make sure whatever you do that you keep it consistent. So when I'm trying to find the height of the real television, I'm going to set it equal to my scale factor. That 1 centimeter is equal to 10 inches. And what it gives me is, and remember this is for the centimeters is for the model of the television, and then the inches is for the actual television. So when it tells me the height of the television is 5 centimeters in the scale model, I'm going to put that on the top of the proportion so that it's centimeters on top, inches on the bottom. We'll put X for the unknown, which would be the height of the real television. And once you set up your proportion, just cross multiply. 10 times 5 is 50. 1 times X is X. So we get 50 inches for the height of the real television. So you are correct there. And then it's the same process for part B. You're going to want to put your scale factor in there, 1 centimeter over 10 inches, equal to the length of the real television being 80 inches. Make sure you put that where it lines up with the inches of the scale factor, so on the bottom. And to find the length of the television in the scale model, that's our unknown. That's what X will be. So then you cross multiply. 10 times X is 10X. 1 times 80 is 80. Opposite of multiplying by 10 is dividing by 10. And X equals 8. All right, so 8 centimeters is how tall the scale model television is. All right, so thank you so much for joining the lesson. One way that I'll end off this recording, just to kind of let everyone know who watches it, is that between today and tomorrow, depending on how much time you actually need to finish working, I will be calling you and your parents to confirm your final grade. Now, if you have an A, I'm supposed to call twice for everyone, and then if you don't answer, I'm supposed to leave a text message, but I'll still call. For those that have an A, I'll call once, and if you don't answer, I'll leave you a nice text and congratulate you on all your hard work that you've done. Everyone else, I'll make sure to follow that. I'll call twice and then leave you a text in that case. But I'm supposed to confirm final grades with every single person. Tomorrow's the course end date. So if you do use all of tomorrow through midnight to complete assignments, to resubmit stuff for a higher grade, then you can expect that phone call to be June 30th. All right, but it has been great being your instructor. If you haven't taken your semester exam, I wish you the best of luck on it. The semester exam is just one attempt, so do take it seriously. Go through the other review materials if you like. You can still play the Jeopardy game by yourself if you wish. All right, sorry, I have no clue what happened, but thank you for joining. I did get all my messages out, so have a great rest of your day. Thank you. Have a good one.